Okay, this is on. So I am doing question 6. State the transformations applied to the base of the following graph. Question 6, the base function is y equals 3x. Alright, so... oh, gosh. No, okay, so the negative sign, we're going to start off, since there is a negative sign in front of the 3, that means that it is being reflected over the x-axis. Reflection over x-axis. Being reflected over the x-axis. Reflected over the x-axis. And then we have y equals negative 3x. Okay, so now there is a minus 2 beside my x, which means a horizontal translation. It's a negative, which means it is not going to the left, it is going to the right by 2 units. Horizontal translation. I got this papers. Horizontal translation right by 2 units. And lastly is a plus 1 at the end of my equation. Y equals negative 3x is 2, and then a big old plus 1, which is a vertical translation up by 1 unit, which is stated here. Up by 1 unit. Alright, that was the first one. On to the next one. Okay, so my base function is y equals 1 over 3x. So the transform function. So my first thing is there is a 1 over 3 in front of my 1 over 3, which means it is a vertical transformation. Whether it is not a stretch because the factor is smaller than 1. It is a vertical compression by a factor of 1 over 3. Vertical compression by a factor of 1 over 3. Okay, next is... there is a y equals 1 over 3, 1 over 3. Okay, now x is being added to, which means there is another horizontal translation. This time we are going to it's a plus, so that means we are going to the left by 2 units. Horizontal translation, left by 2 units. Okay. And the last one is a minus 1. Y equals 1 over 3. 1 over 3. X plus 2. And then a big old minus 1 at the end, which means a vertical translation down 1 unit. Vertical translation down 1 unit. Alright, and last but not least, number 3, where our base function is y equals 2x. So the first, there is a negative sign in front of our exponent, which means it is a reflection over the y-axis. Reflection over the y-axis. And there is a minus 2 again after exponent, x minus 2 minus 2, which is a horizontal translation. Just a horizontal translation. Oh god. minus 2, negative, normally shift to the left. So no, it is a horizontal translation right by 2 units. For God, this is disorienting. Horizontal translation right by 2 units. On a piece of graphing paper, graph one of the following functions by first graphing the base function provided. Your graph should... Okay. Alright, next I'm gonna graph. I'm just going to graph number 3, y equals negative x minus 2, because it has the least steps. And I'm running... I'm not doing so hot on time. Okay, let's go. So this is... Okay, on a piece of graph paper, you graph one of the first by graphing the base function provided. Your graph should contain labeled equations, at least 3 points, an appropriate scale, work shown for all steps of the graphing process. Okay, so this is still 6. I'm gonna draw out my graph. Make this fairly big because I can't read very well. -1, -2, -3, -4, -5. -6. 1, 2, 3, 4, 5, 6, 7. -1, -2, oh, jeez, that's way off scale. Okay. 2, -3, 5, -4, -5, -6. 1, 2, 3, 4, 5, 6. Okay, that looks about right. This will be my base graph, what I'm going to start off with. I mean, it's just the plane. This is the graph plane I'm going to graph on. Okay, so what did I say I was going to do? I was going to do number 3. So my base function is, so first we are doing number 1, which is first transformation, which is just y equals 2x. Okay, so when x is 0, y is 1. When x is 1, to the power of 1, x is 2. When x is -1, to the power of -1 is 0.5. And so on. 2 to the power of that would be 4. And then you just kind of divide. So this would follow suit like that. So you can see there we have all of our corresponding points to the x values or y values that correspond with our x points on our graph. I should probably make a table of values so I don't get confused. Okay, x, y, -2, 0.25, -1, 0.50 is 1, 1 is 2, 2 is 4. Jeez, I'm glad I picked 2 as a base when I was doing the graphing assignment. Okay, table of values corresponds with our graph. Next transformation. 2. So y equals, we're going to do the reflection next. So, oh, geez, that doesn't look like a y. Okay. X, y. So, -2, -1, 0, 1, 2. I'm going to use a calculator just so I don't mess up. Two to the power of -2 is 4. We're basically just reversing our values. And then this thing will go in the opposite direction. Same thing as graphing a fraction. Jeez, you can't even... sorry. Okay, so we're basically just putting everything in opposite order. 0.5, 2. I'm gonna color code this, or maybe no, you know what, I'll just do a dashed line. Okay. So, -2 is 4. I mean, it is a reflection, so -2 is 4. -1, when x is -1, y is 2. When x is 0, y is still 1. When x is 1, y is 0.5, and when x is 2, y is 0.25. And now we can graph this. Let's use a dashed line this time. We can see the dashed line corresponds with our table. That is the second transformation. Alright, the third transformation is a horizontal translation, right by 2 units, because it is a -2. So we are subtracting -2 off of all of our values. No, we're adding 2 to all of our values. Yeah. Okay. X, Y. Going right, so we're adding 2. It's just a shift right. Since my old values don't really correspond so well, I'm just gonna 0. 0 is 4. 1. 1 is 2. 2 is 1. 3 is 0.5. And 4 is 0.25. And -2 doesn't fit on my graph, so this time I'll do a little a larger dashed line. Okay. So first we have our base function, which is 2x, then it experiences a reflection over the y-axis, and then a horizontal translation right by 2 units, which I have illustrated here. The straight line is the first transformation. I mean, the hard line is the first transformation, the smaller dashed line is the second transformation, and the longer dashed line is the third transformation. Thank you. Oh, this is a long video.